we can generate sequence vectors. Okay, this can be accomplished by using the sequence operator, SEQ operator. Sorry, sequence function, sequence function, which has 3 parameters, from, to, by. For example, this statement, numbers is assigned frequency from 0 to 100 by 10, means start from 0 with intervals of 10, and the maximum value should not exceed 100. Okay, so what this will do is that we generate the following numbers: 0, 10, 20, and so on. Okay, intervals of 10. So you can see it generates 0, 10, 20, 30, up to 100. Okay, is it clear? Is it clear, please? Now try it out yourself and see. Suppose I say 1 here. Or let's say I say 5. What output do you expect? Are we there?
Okay, it will start from 5.
And stop where?
100.
No?
You start from 5.
Stop 95.
Yeah. Why? Because, Charles, can you see the reason now?
Yeah.
5, 15, 25. When it gets to 75, next is 95. Next is what? 85,
100.
95. The next, if you add 10 to this, what will you get?
105.
100.
Which is higher than the limit that you specified.
Yeah.
So it will not display that one. It will stop at 95. Okay? So that's how the sequence operator works.
What's the use? What's the use?
Well, the use is just what you are seeing. We want to generate numbers automatically, with a particular interval. Okay? There are times you need that. There are times that you need that. All right. So when you don't add the by attributes, it will use a default of 1. Are you following?
Yeah.
Let me remove this so that the numbers will not be too much. So you can see the output easily. Let me use 20. Okay. To use 1. 0, 1, 2, 3. You see? All right. We use the default of 1 when you don't specify the by. Okay. What will this do? Why? What would this do?
Because you said it should start from 0.
Yes.
It's greater than -1.
So what will happen?
That's why it's showing error.
Because I said it should start from 0.
Yeah. I don't think it will be able to display the answer if it's by -1. Oh,
Yeah. So even if it's negative numbers, it works too. That's what I'm trying to show you. However, you must use appropriate numbers that will make it work. If I put 20 here, it's not going to work. Why? Why? Because this will create an endless sequence. Okay? Because I'm saying it should start from 0, stop at 20 with increment of -1.
-1.
So it will never get to 20. I hope you know that. So what you have will be 0, -1, -2, -3, -4, -5, -6 to minus infinity. It will never reach 20. So arrow takes notices that and refuses to run it. It gives you an error, right? So you must use appropriate signs so that it will not create such a problematic situation. Okay. All right. So I think that's enough for that. Okay, so we've been doing things like this. If you do this, this will simply this will simply generate a sequence for you from 1 to 50, no, naturally. Okay. We use that such sequences a lot. So if I say 1 to 100, it's going to generate numbers from 1 to 100 automatically. Okay. So this is a sequence of its own, shortcut type of sequence. Okay. Vectors. Now, to find the size of the length of a vector, that's the number of elements in a vector, you use the length function. Use the length function. Like our vector, how many elements do we have in our vector? Ages. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you do length of ages, we give you 10. Okay. Is that clear? Is it clear?
yes, sir. It's clear.
length of edges what will be the answer? What will be the answer to this? That will be 4, right? Because I'm trying to get the length of all the elements from element number 3 to 6.
To 6.
Yeah. Are we trying some of these commands? And just enter at least one of each type into your own system so that you can have it with you. Are you done? Are we okay?
Yes, sir.
Okay, so now we have been dealing with vectors. I'll be dealing with vectors, which is the first, right? The first and the simplest R object, R data object. The next one is metrics. So let's see what matrices are like. A matrix stores two-dimensional data sets with columns and rows. So a matrix, unlike vectors, can store data, organize data in 2 dimensions. In other words, matrices have columns and rows. Arrays don't have columns and rows. They just exist as one dimensional entity. Okay. So a matrix can be created using the matrix function. Just specify the n row and or n call parameter to get the amount of rows and columns. By row and by call arguments can also be used to specify how the items should be organized in the matrix. Creating a matrix. How do we create a matrix? We use the matrix function. We just supply and supply the values in the form of a vector. And then you specify your n row and your n call. That talks about the number of columns and number of rows. Okay. But you have to ensure it is balanced. In other words, the row times the column must equal the number of items, number of elements. Okay. Like here, we have 3 times 2 is 6. So, and we have 6 items to be represented or stored in the matrix. So this statement is in order. Okay. This statement is in order. So if you do this and then you print it out, you see the matrix. So just run this at your end and then see what it's like. Please run this. You don't need to type this one. You don't need to type this one. That's just a remark. Type this, this, and this. So that's the codes there. So when we run them, we have this output here. 3 rows, 2 columns. Okay. So let's go back to the slide now. So in the same vein, you can run this, you can create this matrix. This is a numeric matrix. This is what?
Character
This is a character matrix. Okay.
matrix.
Why? Because this one contains character values or strings.
Yeah.
Yeah. So if you run this, you see it's similar to just similar. You want to run it or you have done that already, or we'll move on.
Yeah, we're running.
You are running it.
Yes, sir.
Okay. Please, let's do it quickly so we can move on.
Okay.
What did I say this will give just now? Row 2, row 1,
Row 2, row
all the
1, and
columns.
all the columns.
So that's 2, 5, 1, 4.
Yeah.
Okay. So let's capture it. How do we add more columns? How do we add more columns to a matrix? To do that, we use the cbind function. Cbind function. Okay. Use the cbind, that's column bind function, to add additional columns to a matrix. Okay. So by matrix 2, that's my matrix 2 containing apple, banana, and so on. And row equals to matrix 3 equals cbind matrix 2. Okay. And then you add a vector there. So when you display matrix 3, you see what has happened. Okay. You see that a column has been added. How many columns are this matrix originally? Matrix 2. How many columns are there in matrix 2?
2.
Um, see what? You can see that it's 2, right? Not rows.
Yes, sir. It's 2.
It's 2 because there are 4 items, 2 rows, so there has to be 2 columns. Okay, so that cbind function adds another row, another column, sorry. It adds another column. Okay, so you can see there's a third column now containing the strawberry and all that. Okay. In the same vein, arrow bind adds rows to a matrix. So you can use the cbind and arrow bind to add columns and rows respectively.